In linear algebra, we're looking at essentially three things and how they interconnect to each other. Remember, linear means a straight line. So we're going to either have the equation for the straight line, some sort of pattern, typically in a table, and a graph. Now our graph will be on a Cartesian plane. So we've got a y-axis, that's the vertical axis, and our horizontal axis, the x-axis. This point right here, the center, is called the origin. That's because on every graph, that's where we start from. And we say the origin is at the point 0, 0, because the x-coordinate, how far across we are, is 0, and the y-coordinate, how far up or down we are, is also 0. Always on a graph we should mark in some sort of scale. I'll put in my y-axis now as well. Same scale, so I can see that for when I'm going up my x and y axis, it's going to be nice and the same. Okay. When I have my picture of either my table or my equation, because it's linear algebra, it'll be a straight line. What we need to be able to do is to move freely between a graph and an equation and a table and a graph, or in the other direction. If I've got the graph, could I make a table? If I had the table, could I write the equation? And if I had the equation, could I make a graph? So there's 6 different things we're going to do here, and I'm going to give them a difficulty rating from easy, 1 star, 2 stars, all the way through to 5 stars, being our most challenging. Okay. So let's, for no other reason than somewhere to start, let's start with an equation. An equation for a straight line can always be written in the form y equals mx plus c. And later on we'll come back to what m and c are. But for our example, we'll use the equation y equals 3x plus 2. Okay, if y equals 3x plus 2, I want to be able to make a table from that, or I want to make a graph from that. Let's look at making a table first. So from an equation to a table. Okay, this is a 2-star skill. Okay, they're pretty shonky looking stars, but they'll do. Okay, so my table, in this case, I'm not told any particular x values to use, so I'm just going to pick some. I'll go for x, -2, -1, 0, 1, 2, and 3. I need to find in my table the y values. I know the relationship that exists between x and y. Y is the same as 3x plus 2. So whenever I know my x value, I can use this relationship to work out the y value. For instance, when x is -2, y is 3 times -2 plus 2, which is -4. 3 times -2 plus 2. When x is -1, y is 3 times -1 plus 2, which is -1. 3 times -1 plus 2 is -1. When x is 0, substituting that in, I'll get 3 times 0 plus 2, which gives me 2. X is 1, x is 2, and x is 3. So I can use my equation to fill out my table. All I'm doing is substituting in the x values into the equation. And that's really a 2-star skill. Okay, another 2-star skill I'd say would be taking the table and plotting it on the graph. And for many of you this may even be just a 1-star skill. Okay, let's give it 2 stars for now, because there are a couple of mistakes people tend to make. I need to take each of these combinations, -2, -4, -1, -1, and so on, and plot them onto my graph. Okay? It's important that I plot them as pairs, x, y. Remember, x is across from the origin, and y is up or down. So I can plot these points here. They will be -2, -4. So x is -2, go back 2, and y is -4, come down 4. I've got a point right there. That's that very first one. The second one is -1, -1, and I've got a point at -1 on the x-axis, come down to -1 on the y-axis. There's my next point. And so on. 0, 2, 0 this way, and 2 this way. 1, 5, x is 1, y is 5, 2, 8, 2, 8, 2, 8, 2, 8 is there, and 3, 11, which will be further up. So there I've been able to take a table, turn it into some coordinates, 3, 11, and I've got my straight line of points. If I was to put a ruler through those, and if I'd drawn it a bit more neatly, they would all line up on a lovely straight line there. Okay, pretty much a 2-star trick. The problem to remember, the piece to remember, is that x before y, just alphabetically, x before y, across x, and then up or down y. Okay, another easy part is moving from our graph back to our table. And that's really the easiest of all the skills. From my graph back to the table, it's a 1-starer, and basically I'm just reading the points off the graph. Here we're plotting the points. So from the table to the graph and the graph to the table are relatively simple. From the equation to the table is relatively simple. Now, we've got the graph to the equation and the equation to the graph. This is where this piece comes in. It's y equals mx plus c. Any straight line can be written in this form. Okay, any of them can be written in this form. But what do m and c mean? If you see on our graph here, we can see that when x was 0, y was 2. If x is 0 in our equation, y is 2 in our situation. Well, if x is 0, mx plus c equals m times 0 plus c, it's just c. So c here must equal 2. Now c, just some notation we use, but it has a special name. It means that the y-intercept is the point 0, 2. When x is 0, so we've not moved across left or right, we're just going up or down, this line we've plotted crosses at 2. So our y-intercept is 0, 2. Our y-intercept will be the c value. So here, in our situation, the y-intercept is 2, and I can see that my equation ends plus 2. If my line was moved up, say it was up here, and was cutting through at 6, then c would be 6. But cut through there. But where does the 3 come from? M is the gradient of our line, and it's the rise over the run. That's how much we go up or down when we move across, and we always move across to the right. So here, when I look at my graph, if I start at any point, I've come across 1 and I've gone up 3. Across 1 and up 3. So in my situation, m equals 3 over 1, which is 3. So my gradient is 3, m is 3, and my y-intercept of 2, there's my 2. So the equation for this graph here is y equals 3x plus 2, because for every 1 across, I go 3 up. The gradient here is 3. The plus 2, my y-intercept is plus 2. So to go from the graph to the equation, it's quite tricky. We'll give that 4 stars. We need to find the y-intercept. And we can just read that off the graph. It's where the graph cuts the y-axis. And the gradient. Remember, the gradient is rise over run. How much do we go up or down as we move across to the right? So we've got 1, 2, 3, 4 of our pieces completed. We've got 2 to go. Okay. Well, from the equation to the graph, I could either make a table and then plot some points, and that's fine. Or I could do it a bit more simply. A straight line, I need to know 2 points. Once I've got 2 points for my straight line, I can plot the whole thing. So I'm going to give this 3 stars because it's not too hard. Yep, and we want it to be easier than a 2 star followed by a 2 star. I'm going to find the y-intercept, and we do that by putting x equals 0. When x is 0 in here, y equals 2, so my y-intercept should be the point 0 for x and 2 for y. And there it is there. I can plot that point if I didn't have my graph here already. Okay. And then I'm going to use the gradient. My gradient here is 3. So if I've plotted this point here, I know the gradient's 3. If I go across 1, I must go up 3. 1, 2, 3. When I've got 2 points, I can put a straight line through those. And I've chosen these 2 points because they're quite useful. It's very easy to find the y-intercept from this equation in this form. It's just this plus c. And then the gradient is this number here. I go across 1 and up 3. That gives me 2 points, and then I can draw on my straight line. The trickiest and final piece is if I've got a table, how do I find my equation? Now this is our 5 star. Okay. Now I don't know that this equation is 3x plus 2. I know it's going to have this form. All I know is I've got these pairs, -2, -4, -1, -1, 0, 2, 1, 5, 2, 8, 3, 11. So when x is 0, I'm really lucky. I'm given x is 0 here. What's my y value? It's 2. The same as down here. When x is 0 along here, my y value is 2. So that tells me I must have a plus 2 at the end of my linear equation. So, first up, what is y when x equals 0? This is c. Whatever y is when x equals 0, that's our plus c at the end. Could be a positive, could be a negative. Okay. Now the second part, I want to find the gradient. What I notice here is I'm adding 3 each time here at the same time as x is going up by 1. I'm adding 3 every time I'm going up by 1. This here is our rise, and this here, the differences in the x is our run. So we say, what are the first differences? In the y values. In other words, how much are the y values going up each time when the x values go up? This is rise over run, which equals our m. Here, the rise each time is 3, the run each time is 1, and 3 over 1 gives me 3, which is our m. So we can now move seamlessly between an equation, a table, or a graph in any direction, in any way.